What's up, math scholars? Thanks for joining me for this video. We are going to talk about the study guide today and probably get, I don't know, first half done. There's 15 problems, so maybe we can get the first 6 or 7 done. I'm not sure. We'll see how it goes. So, who's excited? We have our first math test next Tuesday. Yeah! Woo! Don't forget to bring your Chromebooks. All the multiple choice problems will be on the Chromebook, and then after you finish the multiple choice section, I'll hand out the paper pencil section, okay? All right, so number 1 is the standard form, vertex form, or intercept form. Standard, very good. If you didn't look at the very, very back, I put the formulas on there, just in case you're studying at home and you want to see the formulas. But they will remain on my board. So standard form, the formula we're interested in is x equals negative b over 2a. In this case, the b value is a positive 2, and the a value is a negative 2. Now, I'm having students typing this all in at once, which is fine, but if you're going to type it in all at once, you're going to need to group that bottom. Right? My top number ends up being a negative 2. My bottom number ends up being a negative 4, which is a positive 1.5. So it's your first half of your vertex, and it's your axis of symmetry. How do we get that second half of our vertex? Plug it in. So that 1/2 will go in for x here and here. So can I just have a volunteer who would type this in and tell me the answer so I don't paper type it myself? No. Just do it out of the goodness of your own math scholar heart. Yeah? 4.5? All right, 4.5. Give me a thumbs up if your group got 4.5 when you plugged it in. All right, good. So we do have some people verifying the answer. I'm going to go to 1/2. I'm going to go up to 4.5. 1, 2, 3, 4, 5. And I'm going to do my best job I can at plugging in the graph I'm seeing on my screen. I need to get it on my screen real quick because I grabbed a student's calculator and she doesn't have it typed in. Thanks, but no thanks, Taylor. She cleared it, she said. She told me it was 4.5. Yeah, do you know that my smartboard is never lined up right? So how's that for you? He was being mad that my dot wasn't in the exact spot, so I apologize. I lined my smartboard up and it just never stays aligned ever. All right. So it looks like it's crossing at about -1 and at about 2, and it's opening down. So this is my picture. Okay. Questions on that one? Number 2. How would this graph be affected if the equation were changed from 3x squared to -1/3 x squared? What would you guys put? How would the graph be affected? I would say that it would flip upside down. And get wider. That a value out front of 1/3 would be real wide, and if it was negative, it would be upside down. Okay, easy enough.
What can you say? One from max to
Oh yeah, so you this would actually just be a multiple choice problem. This would totally be a multiple choice problem, so I think you would just select the choice that described the change properly. All right, we get to do some factoring. Anytime you see only 2 terms, it's not going to be old-fashioned method or box method. It's probably going to be a perfect squared method, and that is the case here. 49 is a perfect square, and 144 is a perfect square, so you can just square root those things. The square root of 49, y squared, is 7y. And the square root of 144 is 12. Now it is important to have one positive 12 and one negative 12. You have a factor. Any questions on part A? Part B, there is no number out front, and we have 3 terms, so I call this the old-fashioned factoring technique. It's the very first one you learned this year. You're brainstorming numbers that multiply to -44, that would add up to 20. Can somebody tell me what numbers your groups came up with? Here? They went with a positive 22 and a -2. I agree. Part C was probably the one that the most groups asked me about when I was walking around. It is only 2 terms, but neither one are perfect squares. And there's that cube. Totally awkward. So I told them, why don't we look for a common monomial? A common monomial can be a number or a variable or both. And in this case, it's both. It's a number and a variable. It's 6x that both of these terms have in common. Once you remove that 6x, you're left with an x squared in the first slot and a negative 49 in the second slot. And then hopefully you recognize these two as the perfect square. So you can do that perfect square factor technique. Don't lose your puppy, so keep that 6x out front. But if you would square root x squared, you get x. And if you would square root the 49, you get 7. Make one a plus and one a minus, and you have your answer. Any questions on that? All right, most people did recognize that in part D we were going to head to the box, but wait, don't head to your box till you pull out that common monomial. In this case, that common monomial is a 2. That leaves us with 3x squared plus 11x plus 10. This stuff is the stuff that we can box up with. We're kind of lucky. They're all positive numbers. That should be pretty easy. Turn my little box. We're going to have our 3x squared in the upper left box, our 10 in the lower right box, which multiplies together to give us a 30. What numbers will multiply to give me 30 but add up to 11? I heard somebody whisper it. 6 and 5. 6 and 5. I put my 6 in my upper row, but it doesn't really matter. You could have put the 6 in the lower row. Pull out the top row would have a common 3x in common, and then I can follow my Punnett square around. 3x times x would be 3x squared. 3x times 2 would be 6x, and x times 5 would be 5x. So for your final answer, don't lose your puppy. Put that 2 out front that you pulled out a real long time ago with a 3x plus 5 and an x plus 2. First page is done. Sweet. Question?
So how can you put the 6x out front for C, but you can put the x out front?
All right, number 4. Let's write this in standard form and then graph it. So I might need to move my graph out of the way to do my foiling. Just a reminder, you would always FOIL that 2 only to the first group, not to the second group. So that would give me a 2x plus 4 in my first group. And now we get to do all our rainbows. Here goes. That rainbow is 2x squared. That rainbow is negative 6x. This rainbow is 4x. And this rainbow is negative 12. We're going to combine these two and get negative 2x minus 12. And that's it. Now, the Nathan Carley group over there had a really good idea. They're like, if we would stick this into our graph and graph it, and we would stick this into our graph and graph it, that'd be a great way to check that we FOILed correctly. So I love that idea a lot. Let's go ahead and graph our results. The intercept should be positive 3 and negative 2. And then it should be opening up. Can I just borrow somebody so can I get my run? Actually, I'm just going to borrow a calculator. No, if you pass me real quick. So yeah, I'm just borrowing her calculator so I can get my Vertex. My Vertex is actually down off the viewing screen. So it must be down there like at negative, beyond negative 10. So kind of draw that it goes off the screen and it comes back onto the screen. So yeah, do you see what she's doing? It must be down off the screen. Make sure you're correct. All right, questions on 4? All right, 5. We're doing good. Oopsies. Solve by factoring. What method of factoring did you guys use? If you got this one yet. Box, you're very correct on that. So let me draw myself a box. There's no common monomial. You want to make sure you've got all the common monomials out. You want to make sure you're set equal to 0. So thank goodness we are set equal to 0 there. 2x squared in the upper left box. Negative 3 in the lower right box. Multiply together, get negative 6. And I lined it up before you guys got here, I promise I did. All right. What two numbers multiply to negative 6 that would add up to negative 5? 6 and 1, yep. 6 and 1. We're going to make the 6 the negative and make the 1 a positive. So what do we have in common in our top row that we can pull out front? A 2 and an x. 2x times x is 2x squared. That's an x up there. 2x times negative 3 would be a negative 6x. And then x times 1 would be 1x. So factored form over there on the left would be 2x plus 1 with x minus 3. I'm going to have to move it down a little bit. Or just All right, pause my recording so I can pull this down a bit. To write it in factored form, it will be x minus 3 with 2x plus 1. Now, just a reminder on how you get solutions. Since all of that stuff is set equal to 0, to find your solution, each binomial gets set equal to 0. So x minus 3 equals 0, or 2x plus 1 equals 0. Solving this binomial is easy. You add 3 to the other side, so 3 is your first solution. Solving this binomial, you'd subtract your 1 to the other side, and then divide by 2. So negative 1/2 is your other solution. So 3 and negative 1/2 are your two solutions. I don't necessarily like putting a comma between them because it's not really a vertex or anything. So maybe just write x equals 3, x equals negative 1/2. All right, so number 5 looking good? All right, I think that's time to be number 6. Number 6, solve by factoring. What's our factoring technique that we're going to want to use? Yeah, we only have 3 choices, really. Here's your 3 choices. Old-fashioned method, which is like the regular method, the one we learned first. We've got the box method, and then we've got the perfect squares method, which normally, if it's the perfect square method, there's only 2 terms with a minus sign in the middle. Box method, there's going to be 3 terms with a 1 out front of the x squared. And then old-fashioned method, there's going to be 3 terms, but you're going to have a number out front of the x squared. That's what makes it. I had that reversed. Old-fashioned is when you have that 1 out front. Box is when you have a number other than 1 out front. There we go. You can use that to refer to. I wouldn't leave that up for the test or anything. But it's definitely old-fashioned method. What numbers multiply to 5 that add up to negative 6? Beware of the double negative. It's negative 5 and negative 1. That makes our solutions a positive 5 and a positive 1. We'll do the next one and then call it a day. Sound good? I was going to say, let's do number 7 and call it a day. And then I looked at the study guide and it's number 3. Very strange, but I'm sorry about the numbering. Didn't notice that before I made my copies. So what numbers multiply to negative 16 that add up to a positive 6? What are you guys going with? A positive 8 and a negative 2? All right, so that makes our answers a negative 8 and a positive 2. Alrighty, well thanks for watching our video. That was the first 7 problems of the study guide. That's around half. We did well. There is no homework tonight other than don't lose your study guide. If you think you will lose your study guide, just give it to me. I can keep it for you. Alrighty. Thanks for watching my video, people at home.
I know.